Okay, in this part, linear differential equations with constant coefficients, part 2, higher order. And in previously we have solved the part 1, linear differential equation with constant coefficients, having distinct roots, having equal roots, and having uh, the complex number, roots of complex number. There are three rules for that. Now today we will start part 2. Okay, linear differential equation when right hand side is not 0. Okay. Mm, Suppose there is, if y equals to capital Y is a complete solution. Okay, y equals to capital Y is a complete solution of the these types of differential equation. Actually, this is the nth order differential equation. D to the power n plus d means what? Capital D means what? ddx. A1 d1 d n minus 1 plus dot dot n into y equals to 0. And y equals to b is a particular solution of this differential equation. Hence, y equals to small y equals to capital Y plus b is a general solution of the above equation. And there is actually proof for this differential equation. So there are after solving this differential equation, there are two parts. One is auxiliary part, another is right hand side. So small y equals to capital Y plus b will be the total solution. Uh, and there are two types. One part is small y equals to capital Y, known as complementary function. Okay, complementary function. And capital B, small y equals to b, is known as particular integral. That means there are two parts for this, one for left hand side and other for right hand side. For complementary auxiliary function we get complementary function. Okay, then for right hand side we get particular integral. So total solution will be complementary function plus particular integral. Now concentrate with example. Suppose we try to solve this differential equation. This is actually the third order differential equation, right? D cube and non-homogeneous, d cube plus 3d square plus 3d plus 1 into y equals to e to the power minus x. That means right hand side is not 0. Let this is the given differential equation. Now for auxiliary equation we have this equals to what? 0, right? From the previous lecture. Okay, d cube plus 3d square plus 3d plus 1 into y equals to what will be? 0 for left hand side only. Now the auxiliary equation can be written as with the left hand side. Okay, so d cube plus 3d square plus 3d plus 1 equals to 0. Now let y equals to mx be the trial solution for this auxiliary equation. Okay, so if we take e to the power mx, then d cube what will be? ddx, 3 times differentiation of this, so m cube plus, and 2 times differentiation of e to the power mx, 3m square, and 1 times differentiation of e to the power mx will be m plus 1, and common will be what? E to the power mx will be 0. So auxiliary equation is what will be? M cube plus 3m square plus 3m plus 1 will be 0. This is the actually formula of a plus b whole cube, right? So it can be written as m plus 1 whole cube equal to 0. So there are three roots for this auxiliary equation, for this for the left hand side of this given differential equation. So m equals to minus 1 minus 1 minus 1. That means what? Three repeated roots. Okay, three repeated. So the complementary function yc will be complementary function, just solution for the left hand side. Complementary function will be yc. This is this c for only to understand complementary. Okay, yc equals to c1 plus the since repeated roots. Okay, c1 plus xc2 plus xc3 x square c3, then e to the power what will be? Mx. That means what? Only 1 into minus 1 into x. Okay, this is the actually solution of this auxiliary equation. So this is called complementary function. Remember it, complementary function. Again, for the particular integral, there are another part for right hand side. For having right hand side, this will be what? For particular integral. Now particular integral can be written as 1 divided by d plus 1 whole cube e to the power minus x. Try to this is the actually, this can be written as y equals to what will be? This divided by this. Okay, right? E to the power minus x divided by this. Now particular integral can be written as 1 divided by d plus 1 whole cube e to the power minus x. Since this is the exponential function, remember it. Now we can, if we put d equals to 1, if we put d equals to -1, coefficient of x what actually? Coefficient of x, coefficient x of x -1. If we take this -1 here, then this will be undefined. So after putting uh, single x here, then we can differentiate the denominator. Then differentiation of denominator, what will be? 3d plus 1 whole square is the power minus x, and this will be again undefined for this coefficient of x -1. Okay, so again differentiating this, then you have to put another x in numerator. Okay, x square divided by 6 into d plus 1 e to the minus x. Actually x square by 6, again differentiating this, d plus 1, we get x cube by 6. Okay, differentiation again, differentiation with respect to d will be only 1. This is why x cube by 6 e to the power minus 6. So particular integral yp will be x cube by 6 e to the power minus x. Now the general solution what will be? Complementary function plus particular integral. Just c1 plus c2x plus c3x square e to the power minus x, and this is for right hand side, particular integral 1 by 6 x cube e to the power minus x. Okay, actually we are using these rules. 1 by f of d e to the power x equals to 1 by f of a e to the power x. This integral can be written as like this. Okay, small f of. And this is the number 2 rule. Okay, this is the first rule. 1 by f of d e to the power x equals to 1 by f of a e to the power x. This is the first rule. And this is the second rule. If there are polynomial function, okay, x to the power n, if there are exponential function, then we can write this. Okay, if there are polynomial function, okay, or expression in x, then this can be written as f of d inverse into x to the power n. Okay, then we have to this is expand this. Now if there are sin ax, okay, if there are sine function or cos function, if sine function, then we can convert this minus a square. Okay, d will be convert, what will be? D square will be converted with minus a square, remember it. And if cos x, also same, d square will be converted with what? The coefficient of x minus a square. Okay, the a comes from coefficient. Understand everybody? Now this is the first rule, and this is the second rule, and this is the third rule. We will try to solve these types of example applying these rules now. Okay, this is the another example for exponential function e to the power x. Now for auxiliary equation, we have this equals to what will be 0. Now if e to the power mx be the trial solution of 1, then this can be written as, okay, just putting this upon taking double differentiation, then we get m square minus 2sm plus 2 e to the power mx equals to 0. Just putting y equals to this here. So auxiliary equation will be equal to 0, and m equals to what will be? There are complex roots, right? Complex roots. So the complementary function can be written as e to the power x. One is same for both roots. Okay, e to the power x. Then c1 cos x plus c2 sin x. Coefficient of I is 1, 1x. Okay. Now particular integral what will be? 1 divided by this into e to the power x. Okay. Now e to the power x, x coefficient what actually? X coefficient of x 1, right?
One.
Coefficient of x 1. Just putting x equals d equals to 1 here. In replace of d, we have to put the coefficient according to the rules. Okay, according to the rules, we are putting x equals to 1 here. 1 comes from coefficient of
X.
x. Just putting here, we get this. So particular integral is only e to the power x. So the general solution will be complementary function plus particular integral. Now another 2d cube minus 3d square plus 1. These types of auxiliary equation what will be? Just right hand side, left hand side will be 0. Okay, then taking trial solution y equal to e to the power mx will be the trial solution. Then this is the actually d cube. Okay, 3 times differentiation, so it will give 2m cube, and 2 times differentiation minus 3m square plus 1 e to the power mx. Then this is the auxiliary equation. After solving this, okay, we are, this is the actually three roots here, three roots of m. So after solving this, we get m equals to 1 1 and minus half. So 1 1 will be the repeated roots, right? Repeated roots. So repeated roots can be written as in complementary function equals to will be c1 plus c2 x into only e to the power 1x. Okay, e to the power 1x, then plus c3 e to the power minus half x. Okay, e to the power minus half x, that means minus x by 2. Now for particular integral, what will be 1 by left hand side e to the right hand side. Okay, so if we take this, there will be two parts. Okay, e to the power x into this and 1 into this. There are two parts. So if we take x coefficient, what? E to the power x. In e to the power x, coefficient of x what?
1.
Only one. Only one. Just putting d equals to 1 here. Is it possible to this is undefined, this become what? Undefined, right?
Undefined.
Undefined. So we can take differentiation here. Differentiation, differentiation with respect to d. What will be 6d square minus 6d, and we have to put x for this differentiation. Now e to the power 0, right? This one can be written as what? E to the power 0.
0.
Then so coefficient will be what? X coefficient 0. E to the power 0 into x. Okay, e to the power 0 into x. So putting d equals to 0, right? We get only 1. So this is again a differentiation, because for d equals to coefficient x coefficient 1, if you put d equals to 1 here, this will be also undefined. So taking another differentiation. So for second differentiation, we have another, we have
X
to put another x. So this will become x square. And uh, again, now if we to put the coefficient of
S
1, then it will be only 6. Okay, only 6. Just taking putting coefficient of x, that means putting d equals to 1 here, then this is defined now. So 1 by 6 x square e to the power x plus 1 with the total is the what? Particular integral. Now total general solution will be equals to complementary function plus particular integral. Understand everybody?
Yes, sir.
Now this example also look like a previous example. For auxiliary equation, this left hand side will be 0. So now taking y equal to e to the power mx as a trial solution for this auxiliary equation, we get what? M square plus 4m plus 4 equals to 0 as auxiliary equation. So since this is not equal to 0, this is why this equals to 0. Now this can be written as we get two repeated roots for this after solving for m. Okay, now complementary function c1 plus c2x e to the power mx. Okay, m means what? Minus 2. Just for repeated roots, we have to put this. Now particular integral, what will be? 1 divided by left hand side e to the power into right hand side. Okay, now taking it into two parts. Okay, for e to the power twice x this, and e to the power minus twice x for this. Now if we put d equals to 2, this is defined. Okay, but for d equals to minus 2 coefficient, after if we want to put this coefficient x coefficient what? Minus 2 here, this will be undefined, right? Right, but this is defined. If we put d equals to 2 here, this will be give
Mhm.
real value function. So a real value number. So here second one is failure. So differentiation of denominator, differentiating the denominator of the second twice with respect to d and multiplying by what? X square. That means twice differentiation because they are square. Now just putting d equals to 2 here, then we get this, and this after differentiating and giving x 2 into d plus 2. Okay, just x square formula twice x like this, differentiating with respect to d, capital D. Okay, so again differentiating this, we have to put x square, and this will be what?
S
Only
coefficient
2,
minus 2.
only 2 into 1. Okay, so particular integral can be written as this only, just sum of this. Okay, so the complete solution will be c1 plus c2x plus e to the power minus twice x plus e to the power twice x divided by 16 plus half x square to the power minus twice x. This is the actually result. Very easy, I hope. If you understand any one example for exponential function in right hand side, then you must can solve for any other example. Now another case to
The
determine the
plus sign is
particular.
over.
Okay, just let me finish the 5 minutes only.
1022 है sir.
Okay. To determine the particular integral when x of the right hand side, that means sin x or cos x. Okay, if there are in right hand side sin x or cos x, then we have to put d square equals to what? Coefficient square, coefficient minus a square. Okay, coefficient a comes from coefficient minus a square. Understand? Where minus f of a square will be not equal to 0 because it is denominator. Now just trying to solve this example only. This is the left hand side and this is the sine function. Okay, trigonometric function in right hand side. So you are solving now for the second case of trigonometric function in right hand side. For auxiliary equation, you can write from left hand side this equals to 0. Now if we take y equal to e to the power mx with the trial solution for this auxiliary equation, we get this m square plus m plus 1 e to the power minus e to the power mx equals to 0. So since this not equal to 0, so m square plus m plus 1 equals to 0. After solving this, we get these two complex roots, right? So complementary function can be written as e to the power minus x by 2 minus half x into minus half, then minus x by 2 into c1 cos root 3x by 2 plus c2 root 3 minus sine root 3x by 2. Okay, this is the for complex roots we have already known from our first lecture. So the particular integral what will be 1 divided by left hand side of a sine twice x. Okay, just y equals to now here 2 coefficient what?
2.
2. X coefficient is 2 only, so replacing d square by minus a square, that means minus 2 square. Okay, d square equal to what will be? Minus 2 square. Understand? Just replacing d square equal to minus 2 square. These two come from coefficient, so it is become 1 by d minus 3, right? D square equal to minus a square, right, with d plus 3. So we get minus 1 by 13. D differentiate, d means what actually? D equals to what actually? Differentiation of sine twice x
Sin plus
plus
x.
3 into sine twice x. Okay, so differentiation of sine twice x what will be? Cos twice x, and multiplying with the coefficient of x. Coefficient of x what? 2. So 2 cos twice x
Twice x.
plus 3 sine twice x. And this is the actually what? Complementary particular integral. Sorry, particular integral. So general solution will be what? Complementary function plus particular integral. Understand everybody? So everybody, I hope can do this. And this is also exponential function. You must know. This is the complementary function, and this is the exponential function e to the power x. Just putting what? X equals to 1, it will be fail. Understand? Just take now we have to uh, take another help, that means differentiation method. Okay, now just coefficient of x what? 1. Just d square equal to minus 1 square. Okay, d square equal to what will be here? Minus 1
Minus
square.
1 square.
Then we get this. Then making it a plus b into a minus b, that means 3d plus 1, 3d minus 1. Then another in another side minus coefficient of x equals to 1. So d square equal to what will be? Minus 1 square. Then similar process. Okay, I hope just these two example. Okay, using these two example, you can solve any other exercise of your part.